Good morning, this is Tahmina Khan, TK. This is video number 2 on probability. In my first video, I explained the basics of probability with single events. And now in this video, I will cover combined events, simple combined events using possibility diagram and tree diagram. So again, I'm telling you, this is my blog address and Gmail address. You can reach to that and you can get more help. So let's start. What is simple combined events? Now we will understand simple combined events with the help of examples. So let's start with possibility diagram. So examples of finding probability using possibility diagram. So suppose there is a die in first row and a coin in the and then coin. So first you are throwing a die and then you are tossing a coin, and you have to list all the possible outcomes of the sample space. If you remember, sample space means total possible outcomes. So right now we have to list down all the possible outcomes if I am throwing a die first and then tossing a coin. So I can do it mentally, but to avoid any mistake, I can take help of possibility diagram. The possibility diagram will remind you your junior classes when you drew charts like this, the table like this. So I am taking two-sided. One side I have written coin, head and tail, and the other side I have written die. Die has 6 numbers, so I have written down numbers here. So because I'm throwing die first, so I will write here, first I got 1, then from here I got head. In this case, because it is coming like this horizontally and vertically, so I will say 1 and T for tail. In this case, first suppose I got 2 and then I got head. In this case, suppose I got 2 on die and tail second. So this is how I have listed down all the possible outcomes. So they are total in number 12. One quick way to count how many they are, you can do 2 times 6. So total sample space is equal to 12, and I have listed them down here. So if question says list down all the possible outcomes, you have to list down like this. Now using this table, we will answer few of the questions. So let's see. Suppose the first question is saying, and I have given the name to those events X, Y, Z. I told you event is the outcome, the probability of which I am interested to find out. So suppose the X means getting a prime number on the die and the coin showing head. So if I have to find out the probability out of those 12, how many are showing prime number on the die and the coin showing head? Let's go back to the table. So if you look at the table here, the prime numbers are, usually student says 1, where they are wrong. The smallest prime number is 2. So 2 is the only even number which is a prime number. So the prime numbers are 2, 3 and 5. So, and question says coin is showing head. So it is actually this case and this case. So out of 12, there are 3 cases which are showing prime number and head. So that's why we have written 3 over 12 here. So this is the reason we have written 3 over 12, and in simplified form it is 1 over 4. Now let's find out the probability of Y, and Y mean getting a number greater than 4 on the die. Now before I show you the table, you tell me how many numbers are on the die greater than 4. Simple question. Yes, 5 and 6. So what should be the answer? Can you tell me before I show you the answer? Yes, time up. Okay, so I think you are right, as I can hear few of you. It's 4 over 12. You know why? Because question is saying greater than 4. It is not talking about what is on the coin, either head or tail. So it is 5 head, 5 tail, 6 head, 6 tail. So these numbers are greater than 4. So out of 12 there are 4 such cases, such events. So that's why we have written 4 over 12. So that's why we have gotten here 4 over 12, which we simplify and get 1 over 3. So let's find the probability of z. Now z is what? Getting a number less than 5 on the die. So you tell me how many they are. So you have 3 seconds. 1, 2, 3. Yes, you are right. So less than 5 on the die are 1, 2, 3, 4. Right? Again, question is not talking about which side on the coin. So basically there are 4 2s are 8, because with 1 it will be head and tail. For example, with 1 you have head and tail, with 2 you have head and tail, and similarly with 3 and 4. So all together they are how many? 8 out of 12, and that's why we have written here 8 out of 12, which when we simplify is 2 over 3. Now we will use tree diagram to find out probability of simple combined events. We will see more example of possibility diagram in a while. Right now we are just seeing what they are. So let's see an example of tree diagram. A fair coin is spun twice, right? So we know the coin has head or tail. So this is a tree diagram. The first time when you have thrown, either you get head or you get tail. The second time when you throw, again you will get either head or you will get a tail. So if you look at this, first time you got head, second time you got head, it means your outcome is head. Similarly, if first time you are getting head, second time tail, so your outcome is head tail. If first time you are getting tail, second time head, your outcome is tail head. Similarly, tail. So you have 4 outcomes, and you have seen this is a tree diagram, which might be reminding you your junior English classes when you used to draw tree diagram of your family, starting from your grandfather, then parents, then uncle, and so on. Okay, now see the probability tree diagram. What is a probability tree diagram? When you write probability along the branches, then it is called probability tree diagram. Right now here I am just showing you outcome. I did not teach you how to calculate a probability, right? Though we can count from here also. For example, if I say what is the probability of getting head in both the throws, so you can say 1 out of how many outcomes? 4. So 1 out of 4. So this is also one way, but in complicated cases this is not a good way to calculate. So we will see more organized way also. Probability tree diagram. Now see here, the same case which I have explained you up here. Now I am writing probability along. So probability of getting head is half, and probability of tail is again half. So this is making one complete experiment that you are tossing it. So if you add up these, it should be equal to 1, because 100% probability of any experiment is 1. So that's why when you add up this, it should be 1, because sometimes it is not mentioned here. So how do you write this, or how do you fill it up? You minus this probability from 1 to get this answer. Okay, now this is an independent case. What do I mean by independent case? If I throw one time, I get head. If I throw second time, the probability will not change. So second time throw or will not get affected by the first time, right? So the probability of head second time is also half. So I have written here the probability along the branches. So now if I ask you what is the probability of getting head on both time, you can say half multiply by half. So along the branches you multiply. So it is 1/4, right? If I ask you what is the probability of getting head and tail, first time head, second time tail, so you are multiplying along the branches and you are getting a probability. Similarly, I have found the other probabilities also. So I will go into further detail, but right now I have explained here the difference between just tree diagram and probability tree diagram, and how we will use it we will see in a while. Let's check another example. Okay, so the second example where I will use tree diagram to answer the questions. These are two spinners, right? And there is a pointer pivoted at the center, and they are divided into 4 equal parts. And on first one it is written 1, 2, 4, 5, and in the second one it is written 0, 1, 3, 5. So when I will spin the pointer, it will stop on one of the number. So in this game the pointers will be spun. So we will use tree diagram to find the probabilities. Now there are 4 questions. Now what are those questions? Let's see here. So the questions are: find the probability that the score on each card is same, the sum of the score is odd, the sum of the score is divisible by 5, and the product of the score is not 0. Now by score we mean the numbers written on the spinners. So this is my score. So first I will spin first one and then second one, and then whatever the number will come, if I add up it will be sum, if I multiply them it is called product, or if I just write it down as it is, it will be a score. So let's see how tree diagram will help me to answer these questions. So first let's draw a tree diagram. So here is a tree diagram. I have written first, this is the result of first card which has number 1, 2, 4 and 5, and this is the result of the second card which has number 0, 1, 3, 5. So I have hidden here the answer, the rest I'll show you in a while. How did I draw this? Maybe the first spinner is showing 1, and on the second one I may get 0, 1, 3 and 5. Similarly here, maybe on the first one I get 2, but on the second one I may get 0, 1, 3 and 5. And similarly I have drawn all the branches here. Now let's see. So this is my score. So to make my working easy and be able to answer quickly, I am making a complete tree diagram which will have all the result on it. So first column is about a score. So I am writing 1, 0, 1, 1, 1, 3, 1, 5, or 2, 0, 2, 1, 2, 3, and similarly I am completing the score list along the branches. After that, because in few questions it was talking about sum of the score or product of the score, so I am writing here sum and product also. So for sum, 1 and 0 if you add up it is 1. 1 multiplied by 0 is 0. For example, another one, 1 plus 1 is 2, 1 multiplied by 1 is 1. Similarly, I am completing the table or just the list of sum and score so that I can calculate the probabilities easily. So let's come to the question. The first question was, what is the probability of getting a same card? Now if you see here, same card could be 1, 1, or same card could be, because this doesn't have 2, this doesn't have 4, it could be 5, 5. So basically if you see, this and this. And how many are there total? Will you actually count it, or can you do it quickly? Yes, very good. You can do it quickly, because this is 4 and this is 4. 4 4s are 16. So there are total 16 outcomes, right? So out of 16, there are 2 outcomes which have same number. So if I have to calculate the probability of a same number or same cards, I can say 2 out of 16, which means in simplified form, 1 over 8. And the next question was saying, what is the probability that the sum is odd? So again, we know that total are 16, and I can count how many are odd numbers are here, which I have already counted here. So it is 8 over 16, 1 over 2. The next question was, what is the probability that the sum is divisible by 5? Again, it is saying sum. So if you look at this, divisible by 5 means it should be 5 and it should be 10. So 1, 2, 3, 4. So out of 16, there are 4 outcomes which have number divisible by 5. So we can say 4 over 16. So if you simplify, it is 1 over 4. The last question was saying that the product is not 0. So now we will go into the column of product and we will see how many numbers are not 0. And the easy way is count zeros, because there are very few, which are basically, how many are they? 1, 2, 3, 4. So 16 minus 4 is 8. So 12. So I can say that the probability of non-zero product is 12 out of 16, which is 3 out of 4. So this is how you are using your tree diagram to answer the questions of probability. Now we will see an example of a tree diagram which is a dependent event. Earlier I showed you the case of independent event when we were talking about throwing a coin twice, right? So let's see a tree diagram example which is a dependent event case. Suppose there are 12 people in a group who study either chemistry or history, but not both. 7 of them study chemistry and 5 study history. So if question says about selecting 2 pupils are chosen at random from the group, and what is the probability that they both study history? They study the same subject, they study different subject. The first pupil study chemistry and the second pupil study history. So answer this question. If you can do it mentally, there is no harm, but if the question is saying use a tree diagram, then you must have to draw a tree diagram. So let's draw a tree diagram to answer the question. So just remember, 12 people, 7 study history and 7 study chemistry and 5 study history. And there is no student who is studying both the subjects. So here is a tree diagram. First pupil, chemistry or history. So the probability of selecting chemistry student is 7 over 12 first time, and history is 5 over 12. So second pupil. Now if first time it was a chemistry student, so second time definitely one student has been picked up, and now the total number will be reduced by 1. So it is 11. So all the denominators will change to 11 because one student has gone. But either numerator will change or not, that depends what is selected in the first time. So for example, first time the student was picked up was chemistry. So definitely one chemistry is short. So now there are 6 students in the class of 11. So the second time the probability that you pick up chemistry student is 6 out of 11. Now, if second time you are picking up history, whereas the first time it was chemistry. So chemistry chemistry student has reduced, but the history are still same, 5 in the group. So it will remain 5 out of 11 because one student of chemistry has gone, but history students are still same in the class, which is 5. So it is 5 out of 11. Again here, if the first time it was a history student, the second time the chemistry will be 7 over 11 because history has gone, but chemistry numbers are still same, but denominator is less because one student has gone. I hope it is making sense to you. Now the last case, first time history, second time history. So one student is short, which is 11, and because it was history student, so 5 minus 1 is 4. So you can see that the probability here is not same as it was here. It's different. It depends what was gone out first time. So now if we have to find out the probability, because you have to answer the questions, so to make my working simple, I have written here outcomes and probabilities. So this outcome is chemistry, 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 history, history, chemistry, and history, history. And because if I want to find out what is the probability of both history, I will definitely multiply them because along the branches we multiply, right? So let's see what was the first question. First question was, what is the probability that they both study history? So definitely you will multiply this, right? So that they both study history. Now if the next question is saying, what is the probability that they study same subject? So same subject could be both chemistry or could be both history. So you will multiply this answer, which is 7 over 22. And then you will multiply this answer, which is 5 over 33. And you will add up the two answers, right? Because it is saying both. So when question says same subject, it means history, history or chemistry, chemistry. And I just told you earlier in the first video, when it is or, it means either this or this. So we add up the probabilities. But along the branches we multiply. So when we were saying history, history, we were actually multiply them, right? Okay, so the next question was, what is the probability that students picked up have different subjects? So there are two ways to do it because I know about the same subject. The probability is this. So one way is that you minus it from 1. Remember we studied in the previous video complementary probability, complementary event, right? So complementary is 1 minus what we are not talking about. So if I don't want to talk about same subject, I don't want to consider it, I will minus it from 1. So I will get different subjects. So this is one way of doing it, that you minus it from 1. And what is the other way of doing it? Other way of doing it is that you look at the table. The different is chemistry, history or history, chemistry. So this branch you multiply and get the answer. This branch you multiply and get the answer. And add up these two results. So when you will add up two results, you will get exactly the same which we got earlier when we subtract 31 over 66 from 1, because this was same thing. So the result will come same. And the last question was saying that what is the probability that the first student you pick up study chemistry and second history? It means now you are bound to calculate this probability. First chemistry, then history. So you will multiply and this is your answer. So chemistry and history will be 35 over 132. So with this we will end the second video, which is all about simple combined events using tree diagram and possibility diagram, dependent independent cases. Please press like if you actually have learned something from it, even if it's one little thing, because we should appreciate the efforts. Thank you very much. In my next third video, I will take complicated cases of probability, 4 examples at least, and please do watch it. It will definitely help you to understand and the application of probability better. Thank you very much for watching the video.